Okay, so let's look a little bit more at the ideas of the unit circle and what it actually means for us as far as trig. Why is this in the trig unit? Well, let's talk about that. But first, let's build our radians measure on here. So I'm going to just cover up one quadrant or most of the circle just so you can see this. Now remember to figure out degrees into radians. We multiply by pi over 180. That was in that radians video, the part 2 video. So for example, if I take 30, let's make sure this is on the camera, and I multiply it by pi over 180, I get, well, 30 goes into 180 6 times, so I get pi over 6. So I know this 30 measure is equivalent to pi over 6 radians. That means 3.14 divided by 6 is the length of this radius right here. Okay, let's keep going. If I do 45 and I convert that pi over 180, we get pi over 4 because 45 goes into 180 4 times. So this one will be pi over 4. And if I do 60 is going to be pi times pi over 180 is going to be pi over 3. So what you're going to learn is these are called unit circle values. There are certainly other values that would make up a unit circle, but for some reason, someone long ago decided unit circles should be comprised of only 30, 60, 90, 45, 45, 90, and then the quadrant, what we call quadrantal angles. Okay, so you can see those here. Now let me show you something. How big is a full circle? Do you remember? It's 2 pi. All the way around is 2 pi. Meaning, if I go all the way around in terms of pi over 6, this might be 12 pi over 6, okay? And if I wrote 12 pi over 6, that'd be silly because I can reduce it to 2 pi. If I went all the way around using pi over 4s, this would be 8 pi over 4. Silly to write because that's just 2 pi. If I go all the way around with pi over 3s, it would be 6 pi over 3, but that's silly because that's just 2 pi. So I'm going to keep going now with my 90 degrees. And if I figure out my radians for 90 degrees, pi over 2, wow, that's pi over 180. I know what the answer is, obviously. Pi over 180, 90 goes into itself once and goes into 180 twice. So we get pi over 2. See, a little foreshadowing there. Knew what it was. So we get pi over 2 for that radian measure. Okay, here's the beauty of unit circle and reference angles. You ready? I don't need to know anything other than this first quadrant. If you look online at some other videos, some will talk about this being like 5 numbers, okay? You have your quadrant, your 90, your 0, your 90, then you have your 30, 45, and 60. And if you can remember those 5 points, they mirror image each other all the way around the circle. So here's how that works. I'm going to look at blue angles and quadrant angles. Those are the ones at the quadrants. So I'm going to look at blue angles. This is pi over 6. Well, if this were pi over 6, or in terms of 6's in the denominator, it'd be 3 pi over 6, because 3 pi over 6 would be 2. This would be 6 pi over 6, because this would be 1 pi. We didn't write 1 pi yet, we will. We learned that in the first video, and this will either be 0 or 2 pi, depending on how many, if we've gone around once or not at all. If I look at my pi over 6's, remember the pi over 3's also count. So this is 1 pi over 6. This one's actually 2 pi over 6. Why? Because 2 pi over 6 reduces to pi over 3. This is 3 pi over 6. We just talked about that. So what is this one? Well, this is 4 pi over 6, which reduces to 2 pi over 3. I'm going to write that. We'll come back to that. And then that means that this one, which was 4, this will be 5 pi over 6. Okay, then this is 6 pi over 6 because it's a total of pi. That means this next blue one is 7 pi over 6. Okay, go to the pink one would be 8 pi over 6. We'll come back to that. 9 pi over 6. What is 9 pi over 6 reduced? It's 3 pi over 2. 10 pi over 6, and this one would be 11 pi over 6, and then we'd be back here to 12 pi over 6. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pi over 6. We can count it that way. Now I'm going to do the yellows. 1 pi or 0 pi over 4. 1 pi over 4. 2 pi over 4. Does that make sense with pi over 2? Yeah, because 2 pi over 4 is pi over 2. 3 pi over 4. 4 pi over 4. Does that make sense with pi? Yes. 5 pi over 4. 6 pi over 4. Does that make sense with 3 pi over 2? And the answer is yes. 7 pi over 4. And then 8 pi over 4, which makes sense for the 2 pi. Okay, so now let's do the yellows. We've got 1 pi over 3, 2 pi, sorry, I said yellows, I meant pinks. I do know my colors. 1 pi over 3, 2 pi over 3, 3 pi over 3, which makes sense. 4 pi over 3, which we said this was 8 pi over 6, and that works because 8 pi over 6 reduces. 5 pi over 3, and 6 pi over 3 back here, which makes sense also because 6 pi over 3 is 2 pi. So there's our unit circle using radians and degrees. Okay, I would suggest you keep this handy, maybe even rewatch this video again if you need to, but we're going to look at some problems that go with unit circle and what you might see. Okay, go back to geometry again. Tell me what you know about SOHCAHTOA. What does that even mean? Do you remember that SOHCAHTOA, I'm going to cover this for just a minute, that SOHCAHTOA was a way to reference that the sine is equal to the opposite over the hypotenuse, the cosine is equal to the adjacent over the hypotenuse, and the tangent is equal to the opposite over the adjacent. Do we remember that? Okay, why is that important? Well, let's go back to our unit circle. In all of these problems, what's my hypotenuse again? My hypotenuse is 1. So when we say, let's see, is that in the screen? Yep. When we say sine is opposite over hypotenuse, we mean that sine is opposite over 1. Well, opposite over 1 is just the opposite, right? So sine's the opposite. And if I'm in a quadrant or a grid system like this, and I look opposite of this 30-degree angle, which variable does that represent? Well, it represents y. So on the unit circle, sine is equivalent, the sine of the angle that we have, angle we're going to use theta, is equivalent to the y value. Why? Because the opposite is the y value and the hypotenuse is always 1. Okay, so let's talk cosine. If we have the cosine, which is the adjacent over the hypotenuse, and the hypotenuse is always 1, then the adjacent side is this side right here, which is the x side. So the cosine of whatever angle we're talking about represents x. So on a unit circle, when we have a unit circle, anytime I have an ordered pair, let's see where I can write this, that you can see it. Anytime I have an ordered pair, any ordered pair x comma y is equivalent to the cosine of that angle and the sine of that angle. That's what that looks like. Keep that in mind. We're going to use that. You ready? Let's look at an example of what that might look like. So we're going to start simple. We're going to only do the first quadrant. That way you can see the first quadrant. But if I ask you, say for example, to find the cosine of pi over 3, I can look on my unit circle for where pi over 3 is, and we know that the cosine is equal to the x value. I hit it. Hopefully you wrote it down. The cosine is equal to the x value. Oh, that's not on the screen at all. Let's move that down, shall we? So the cosine is equal to the x value. So if I say cosine of pi over 3, I'm asking you to go for where pi over 3 is and tell me what the x value is. It's 1/2. And that's your answer. You could type this in your calculator if you were using radians and not degrees, but most of your calculators are programmed for are programmed in radians probably. It should work okay. You should get 1/2. Now, if I ask you for the sine of 45 degrees. Well, if I look for 45 degrees and I look for the sine, which is the y value, I get √2 over 2. Now, I could have asked you that same question instead of asking for the sine of 45. I could have said, okay, what's the sine of pi over 4? Well, the sine of pi over 4 is the y value for that angle of pi over 4. The y value is √2 over 2. Okay, since I only have the first and fourth quadrant on here, let's say I ask you for the cosine of 5 pi over 3. Take a second and see if you can find it. Did you get 1/2? Cosine is the x value, and at 5 pi over 3, the x value is 1/2. Okay, we can do that anywhere throughout the unit circle. Now, for now, obviously, we're going to use our unit circle or have our unit circle handy. So keep it handy in front of you. I will post a picture of this on my website under the Algebra 2 Trig folder that says Unit 9 Trig. So look for that if you would like to see a filled out copy, just to make sure yours got filled out. And we'll catch up. We'll do an office hour so you can ask questions on this. And obviously there's a lot of cool things we can do with the unit circle that we're not going to get to just yet. Right now we need to understand how the unit circle was built and what we can do with it. All right, you guys, we'll talk to you soon.